Okay, so with this problem where we're solving for the perimeter, I would add all these up to get the perimeter of this thing, and then I would do the same thing with the uncertainties. So the actual uncertainties, this is going to be the error or the uncertainty in the perimeter would be equal to 2 times 0.2 plus 2 times 0.3. Now you could show the math any way you want. You could say 0.2 plus 0.2 plus 0.3 plus 0.3, or you can do it this way. But obviously in this case, 2 times 0.2 is 0.4, 2 times 0.3 is 0.6, 0.4 and 0.6 is going to be equal to 1.0. Oh, sorry. And that would be in centimeters, right? And they were asking to find the area and the perimeter of the triangle. So what I have right now is the uncertainty, and what I need to do is just put the whole thing together. So 8.5 and 8.5 is 17, plus 4.4 and 4.4 is 8.8, so that's going to be 25.8. So our final perimeter, this is going to be P plus or minus delta P, would be equal to, I already lost track of it, 1725, right? 25.8 plus or minus 1.0 centimeters. Oh, sorry. Sorry, I know I have it a little bit low on your screen that you're looking at right now, but it's because I'm trying to make sure it's in the center of the camera as I'm recording this right now. Any quick questions before we move on to the area problem? Anything that wasn't clear? You want me to repeat? Addition and subtraction, you simply add up the absolute uncertainties. It's the easiest of the calculations, but just be aware that they will do little sneaky things like this where actually each of those numbers is not being added together, but you have to double it after that because there's 2 of each. Okay, so that takes care of the perimeter. Let's take a look at the area. Okay, now I am not going to do the range method. Okay, that is a method that everybody should get very familiar with. You should definitely make sure that you can do that. But that is the one that I think is easier. I think that most people will get that in the end. You might still make little ticky-tack mistakes, but you'll generally get the conceptually, it's not that hard to understand. Now, using the formula is a little bit trickier. So in this case, what I would say is that delta A for the area over A would be equal to delta L over L plus delta W over W. Okay, that's our equation. That's the formula. And the reason why is because the formula for this is length times width, right? So that's multiplication is the math. That means that the rule is that I don't add the absolute uncertainties. What I add is the fractional uncertainties. But just realize when I add those fractional uncertainties, it does not give me the I mean, just think about it. How could you add percents together and somehow that turns into a real number with units? This doesn't work like that. You can't add 2 numbers together and they somehow become a different property. So when you add fractional uncertainties together, you still have a fractional uncertainty. But the fractional uncertainty that you have is the fractional uncertainty for the answer to the calculation, which is going to be the length times the width. So we'll do the length times the width afterwards because that's a very easy thing to do. Let's go ahead and start plugging these numbers in. So what I'm looking for is the delta A. Okay, on the bottom of this, I'm going to put the calculation to this, which is going to be 4.4 times 8.5, because again, that's the area. The area is the length times the width. Now on the other side, I'm just going to plug in the numbers as they were given to me. That was 0.2 over 4.4 plus 0.3 over 8.5. All right, so let's talk about options on the calculator. How could you do it? What I would generally suggest is that I'm going to move down to the next line and I'm just going to fill in 2 things. So I'm going to have the delta A as by itself. I need 4.4 times 8.5. That is 37.4. Okay, now on the other side, I'm going to do everything at once. And here, I'll even show you in the calculator what I'm doing here. So that would be 0.2 divided by 4.4. And I can say plus because the calculator knows the order of operations. I mean, I'm assuming you guys have all learned the please excuse my dear Aunt Sally order of operations. And so it will do the division before it does the addition. And that is what I want. I want it to do that. So that is plus 0.3 divided by 8.5, enter. And that's the answer. It's not going to be in a fraction. although you could put it in a fraction, but our final answer should not be in a fraction. We want to put the answer with the correct number of sig figs. So the answer was 0.080748. Now I'm putting a lot of numbers in there because this is not the final answer. This is not the final answer, right? So I haven't finished the whole thing. I have one last step now. In order to get delta A, which is going to be the absolute uncertainty for the area, I just need to multiply this over to the other side, and then I'll have delta A will be by itself. So I've already got the number in my calculator, times 37.4 equals, and the answer is 3.02. Now remember, uncertainties cannot be 3 digits. So we have 2 options for our uncertainty, sorry. 2 options for the uncertainty. I'll give you both of the possible answers. So one possible answer would be delta A plus or minus, I wrote it wrong. A plus or minus delta A is equal to, so it would be 37.4 plus or minus 3.0. And just realize that's square centimeters. Or alternatively, we can cut this guy down to 1 significant digit, and we could say it's equal to 37 plus or minus 3 centimeters squared. And either one of those answers would be acceptable. Now, you did not have to do it this way. It was not a requirement. You could use the range method. You could pretty much use the range method almost everywhere. The only problem with the range method is that it would be easy for you on a multiple choice test to not be able to complete the problem because it's like too much math. It's too much, they don't want you to be doing that kind of math. So they want you to be able to do these. So let's say, for example, what if this was like 10? And what if this was like 20? Well, 0.2 divided by 10, you should be able to do that. That's going to be 0.02. 0.3, let's say it's 0.3 divided by 20. Well, 0.3 divided by 10 would be equal to 0.03. So 0.3 divided by 20 must be 0.015. So those are the kind of little tricks that they will make the numbers so that they are easy to work with without a calculator, or at least relatively easy, so that you don't have to go through some elaborate calculation. So it is important that you are familiar with this, that you understand how to set this equation up correctly, how to look at it in the data booklet and set that thing up correctly in order to be able to address the multiple choice questions. Except for the multiple choice, though, you could always use the range method. I mean, that's the foundation of all uncertainties, is the range method. So you should always feel free to do that unless they are specifically asking you to use this formula. And this is why it's really important that you practice both. You should be practicing both, right? And so that could be as simple as doing the problem over. Do a problem like this and then redo it by the range method. You should get the same answer. And of course, now you guys have the answers to be able to check your work. So hopefully that's going to help you guys out quite a bit. Any questions on what we did here for perimeter and for area? Now's the time to ask.
Mr. Cohen, does delta P, is that equal to the uncertainty?
That would be, yes. And I know that's like it's kind of unfortunate, and there's no way to really get around it because they do use the delta in 2 ways. One to mean the change in something, which is the way I've only ever heard of it. And then the other one is that it means the uncertainty or the error, actually. It can mean either uncertainty or error. Those are kind of used almost interchangeably. So yeah, the absolute uncertainty has the delta in front of the letter. So like delta P, delta A, delta V, whatever. And that represents the uncertainty. So the plus or minus number, essentially.
Okay, thank you.
Sure. All right. Let's see. Doesn't look like any other questions. Let me just ask this, and you can just respond to me in the chat. I'm just looking to see if I have a significant number of people, then we can do this as a class. But if it's only 1 or 2, then I'll just talk with those people. Question number 10 is here, let me stop this.